carbon. Allotropic nature of carbon. There are some elements that occur in nature in more than one form. The chemical properties of these different forms of elements are the same, but their physical properties are different. This property of elements is called allotropy, and the different forms of the elements are called allotropes. Carbon shows the property of allotropy. The elements sulfur and phosphorus also exhibit allotropy. Carbon exists in two allotropic forms, the crystalline form and the non-crystalline or amorphous form. Crystalline forms of carbon. A crystalline form has a regular and definite arrangement of atoms. This gives them a definite geometrical shape with sharp edges and plane surfaces. Crystalline forms have a high melting and boiling points. Carbon has three crystalline forms: diamond, graphite, and fullerene. Let us first discuss about diamond. Diamond deposits are found in diamond mines located in South Africa, Brazil, Belgium, Russia, and America. In India, diamond mines are found mainly in Govalkonda in Karnataka and Panna in Madhya Pradesh. Structure of diamond. A diamond crystal is a giant molecule of carbon atoms. Every carbon atom in a diamond crystal is linked to four neighboring carbon atoms by strong covalent bonds. This arrangement gives diamond a hard tetragonal three-dimensional structure. Let us now discuss the properties of diamond. Properties of diamond. Diamond has extraordinary brilliance. It is the hardest natural substance. The compact and rigid three-dimensional arrangement of carbon atoms in diamond gives it a high density. It has a density of 3.5 grams per cubic centimeter. The melting point of diamond is very high. It is 3,500 degrees Celsius. When diamond is heated to about 800 degrees Celsius in the presence of oxygen, it does not melt. It gives out only carbon dioxide during this process. No other product is formed. Diamond does not dissolve in any solvent. Diamond is not affected by acids or bases. Since there are no free electrons in a diamond crystal, it is a bad conductor of electricity. A peep into the past. Long ago, India was famous for the Kohinoor diamond. This diamond was found in the 13th century in the mine at Guntur in Andhra Pradesh. Its weight was 186 carats. Uses of diamond. Since diamond is extremely hard, it is used in cutting instruments like glass cutters and in rock drilling machines. Due to its extraordinary brilliance, diamond is used in making jewelry. Diamond knives are very sharp knives whose edges are made from diamond. Such knives are used in eye surgery. Diamond dust is essentially the leftover material obtained from cutting diamonds. It is used for polishing other diamonds. Diamond is used to make windows for giving protection from radiation in space and in artificial satellites. Let us now discuss about graphite. Graphite. Graphite in its natural state is found in Russia, New Zealand, America, and India. The lead of pencils is made by mixing graphite and clay. This process was discovered by Nicolas Jacques Comte in 1795. Structure of graphite. The structure of graphite is very different from that of diamond. A graphite crystal consists of layers of carbon atoms or sheets of carbon atoms. Each carbon atom in graphite is joined to three other carbon atoms by strong covalent bonds to form a flat hexagonal layered structure. Various sheets or layers of carbon atoms form a graphite crystal. On applying pressure, these layers can slide over each other. One layer of graphite is called graphene. Let us perform an activity to understand some properties of graphite. Activity. The apparatus required for this activity are pencil, electrical wires, a battery, a small bulb, water, kerosene, 2 test tubes, etc. Let us begin with the activity. First, remove the lead from a pencil and feel it with your fingers. Yes, it is smooth to touch. What color is it? It is grayish-black in color. Now try to break the lead with your hand. Is it possible? Yes, it breaks easily. Let us now set up an electrical circuit using a battery, bulb, switch, connecting wires, and crocodile clips. Insert a pencil between the ends of the crocodile clips. Switch on the current. What do you observe? The bulb glows. This shows that graphite conducts electricity. Now take some water in one test tube and kerosene in another test tube. Put some lead dust in both the test tubes. What do you observe? The pencil lead does not dissolve in both water and kerosene. Let us now discuss the properties of graphite in detail. Properties of graphite. Graphite found in nature is black, soft, slippery to touch, and brittle. In each layer of graphite, there are free electrons moving continuously. That is why graphite is a good conductor of electricity. Graphite has a layered structure due to which it is used in pencils for writing. The density of graphite is 1.9 to 2.3 grams per cubic centimeter. Graphite is insoluble in most solvents. Let us now discuss some uses of graphite. Uses of graphite. Graphite being soft and slippery, it is used to make lubricants. Graphite being a good conductor of electricity is used for making carbon electrodes as well as used in arc lamps which give a very bright light. Graphite is used in pencils for writing. Graphite is also used in making paints and polishes. Let us now discuss the third crystalline allotrope of carbon, that is fullerene. Fullerene. Fullerene is a recently developed allotrope of carbon. It is rarely found in nature. It is found in soot and in interstellar space. Buckminster fullerene, C60, is an allotrope of carbon containing clusters of 60 carbon atoms joined together to form a spherical molecule. It is the first example of fullerene. This allotrope of carbon was named fullerene after the architect Richard Buckminster Fuller because its structure resembled the geodesic domes designed by him. Harold Kroto, Robert Curl, and Richard Smalley were awarded the Nobel Prize in Chemistry in 1996 for the discovery of fullerene, C60, allotrope of carbon. The other forms of fullerene are C70, C76, C82, and C86. These molecules are found in minute quantities in soot. Let us discuss the properties and uses of fullerene. Properties of fullerene. Molecules of fullerenes are found in the form of either spherical balls called buckyballs or cylindrical tubes called bucky tubes. The number of atoms in one molecule of fullerene vary from 30 to 900 carbon atoms. Fullerenes are soluble in organic solvents such as carbon disulfide and chlorobenzene. Uses of fullerene. Fullerenes can be used as insulators. Fullerenes are used as catalysts in water purification. Scientists conducting research in superconductivity have revealed that at certain temperatures, fullerenes show superconductivity. Let us now discuss amorphous forms of carbon. Amorphous forms of carbon. We have learned that in the crystalline forms of carbon, the arrangement of atoms is regular. In the non-crystalline forms or amorphous forms of carbon, the arrangement of atoms is not regular. The non-crystalline forms of carbon are coal, charcoal, coke. Let us discuss each of these forms in detail. Coal. Coal is a fossil fuel. Besides carbon, coal contains hydrogen, oxygen, nitrogen, phosphorus, and sulfur. It occurs in the solid state. Depending upon the percentage of carbon present, coal can be classified into 4 types: peat, lignite, bituminous coal, and anthracite. Peat. Peat is the first stage in the formation of coal. It contains less than 60% of carbon and a large proportion of water. Therefore, not much heat can be obtained from this type of coal. It is the most inferior type of coal. Lignite. Lignite is the second stage in the formation of coal. The peat is compressed due to the increased pressure and temperature inside the earth and thus is transformed into lignite. Lignite contains 60 to 70% carbon. Bituminous coal. Bituminous coal is the third stage in the formation of coal. It contains 70% to 90% carbon. Anthracite. Anthracite is the purest variety of coal. It is the oldest stage in the formation of coal. It has the highest carbon content. It contains about 95% of carbon. Anthracite is a hard, dense, and black solid. Charcoal. Charcoal can be made by combustion of wood in an insufficient supply of air. Charcoal can also be obtained by heating animal bones and horns, etc., in a limited supply of air. Now, let us discuss the uses of coal. Uses of coal. Coal is used as a fuel in homes and factories. Coal is used as a fuel in thermal power plants for the generation of electricity. Coal is also used to obtain coke, coal gas, and coal tar. Let us now understand the third non-crystalline form of carbon, that is, coke. Coke. When coal is heated in the absence of air, coal gas is released. The residue that remains behind is coke. Uses of coke. Coke is used as a domestic fuel. It is used as a reducing agent. Coke is used in the manufacture of water gas. Water gas is a mixture of carbon monoxide and hydrogen gas. CO plus H2. Coke is also used in the manufacture of producer gas. Producer gas is a mixture of carbon monoxide, hydrogen gas, carbon dioxide, and nitrogen gas. CO plus H2 plus CO2 plus N2.